Hello, and welcome to GRC 605 Unit 6 presentation. My name is Lamont Bass, and today I'll be your presenter for Simple Linear Regression. Our agenda is as follows. Number 1, introduction. Number 2, state the hypothesis, rejection rule, and supporting details. Number 3, conduct simple linear regression using PSPP. Number 4, we'll examine PSPP's output and relevant tests. Number 5, I'll offer my takeaways, and we'll be closing with number 6. Our introduction. We are tasked with conducting simple linear regression tests on 3 data sets with given variables and present a regression analysis using PSPP. We will use simple linear regression, which is a statistical method that allows us to summarize and study relationships between 2 continuous variables. And we will use linear regression analysis and statistical processes for estimating the relationships among the variables. Following data set that we were given was generated using a SurveyMonkey survey asking 150 participants located in the Midwest questions regarding their income, debt, savings, and other important personal financial factors. Of the data set, our first regression test: can we predict an individual's debt by knowing their income? Second regression test: can we predict an individual's savings by knowing their income? And the third regression test: can we predict an individual's portfolio value by knowing their savings? For our first hypothesis test, the dependent variable is debt and the independent variable is income. The following regression was conducted. Null hypothesis, the regression coefficient is 0. The alternative hypothesis, the regression coefficient is non-zero. A simple linear regression was conducted to determine whether debt could be predicted from income. There was no significant regression that was found. Following formulas: beta came in as a negative 0.05, the R-squared value 0.00, and the p-value 0.535. In our second hypothesis test, the dependent variable was savings, the independent variable was income. Following regression was conducted. Null hypothesis, the regression coefficient is 0. The alternative hypothesis, the regression coefficient is non-zero. A simple linear regression was conducted to determine whether savings could be predicted from income. A statistically significant regression emerged. Beta came in as negative 0.91. Our R-squared value was 0.82, and our p-value was 0.000. Thus, the test rejected the null hypothesis and predicted savings. Savings equals 0.91 times the income of minus 203.47. Savings is predicted to decrease as income increases. Furthermore, the 95% confidence interval was a minus 0.009 and a minus 0.11, and it does not contain 0, hence lending support to the prediction. And in our third and final hypothesis test, dependent variable, stocks, and independent variable was savings. The following regressions was conducted. Null hypothesis, the regression coefficient is 0. Alternative hypothesis, the regression coefficient is non-zero. A simple linear regression was conducted to determine whether stocks could be predicted from savings. A statistical significant regression emerged. Beta equaling minus 0.28, our R-squared value 0.08, our p-value 0.000. Thus, the test rejected the null hypothesis and predicted stocks equals negative 0.28 times the savings of plus 1006.73. Stocks is predicted to decrease as savings increases further than 95%. Confidence interval minus 0.07 and minus 0.25 does not contain 0, hence lending support to the prediction. Our takeaways from today's tests. Number 1, simple linear regression allows us to model mathematically the relationship between two or more variables. Number 2, the goal is to create a linear model that minimizes the sum of squares of residuals. Number 3, the steps to linear regression in PSPP is to analyze, regression, and then linear. Number 4, an analysis of the standard error, a measure of the variability of a statistic, is an estimate of the standard deviation of a sampling distribution. And number 5, linear regression calculates an equation that minimizes the distance between the fitted line and all of the data points. Thank you for joining me today. I hope you enjoyed. I will be available for any further question or discussions via the CIU student portal. Thank you.